So this diagram right here represents a population. This represents all people. And the example I used was Hancock College. So this represents all students, like 14,000 Hancock College students, right? So all 14,000 Hancock students. We're going to take a sample. I'm going to take a part of this group. There's a sample. And then within that sample, I'm going to find some information about Hancock students. And that sample that comes from here is called a statistic. So the statistic can be represented as usually the most common is the mean or a percentage. Okay. So if I say the average GPA, usually we use this symbol. The average GPA for Hancock students is 2.9. That would be a statistic. So the sample is, let's say I ask 100 people, what's your GPA? Right. And I go around Hancock College during fall and spring and even summer and ask GPA. And I get an average. That number is the statistic. The sample is the 100 people that I asked at Hancock College. The population is all Hancock College students. And a lot of the questions that were in the book, the population was all US residents. Okay. So that is population and sample. Another thing we looked at was parameter and statistics in 1.1. So parameter is, this is a statistic because this comes from the sample. The parameter would be the average GPA of everyone at Hancock. I don't know what that is. I don't know what the average GPA of all Hancock College students is, but I'm sure that's going to be pretty close, right? It could be off by, a couple digits, but 2.7, 3.1, who knows? But the population, the parameter comes from the population. An example of the parameters in our population is a measurement of everything, like the average speed on the freeway is 65 miles per hour for everyone, right? Well, that's the posted max speed limit, but that's usually about the average speed, right, for all drivers. The average height of males is 5 feet 9 inches tall. The average weight of babies is about 7.1 pounds. Okay, so those numbers come from population parameters, data that's collected over time. The average body temperature is supposed to be 98.6 degrees, but it's usually lower than that. But that takes consideration all humans, right? Babies are humans and their temperatures run a little higher. In adults, our temperature is a little lower. So the average is about 98.6 degrees. So that's parameter and statistic 1.1. Any question about any of the homework problems in 1.1? Excluding problem 45. 45. Did anybody do problem 45? I just mentioned it, where you can find a statistic. Go find a statistic in a sample or a parameter, right? So you're going to look in a book or a magazine or a newspaper, find a statistic. And I'm going to spend more time in this area right here because I think I can zoom the camera out. The camera goes to right about here. I want to kind of write in this area most of the time. So that way, when you watch the recording, if I'm over there, you're like, oh, I wonder what that was. Okay, so stay in this area. No question, 1.1. All right. 1.2, we analyze or categorize data. Data could be two things in 1.2. I didn't put that up here. I guess we could have qualitative or we could have quantitative data. So qualitative data, usually you're looking at the mean or an average. So with qualitative data, you're looking for the mean. If you could find the mean, oops, I'm sorry about that. I wrote qualitative first. If you could find a percent, that's qualitative data. If you could find a mean, that's quantitative data. Quantity, that's an amount. So like I mentioned, average GPA, that would be quantitative data. If you're looking at GPAs of students in a college, you're looking at a mean. If you're looking at a percent, what percent of students carpool, right? So we could look at a percentage. We could ask students, do you carpool? And get a percentage, especially now, right? Oh, gas, this and that. Anybody ride a bike now? instead of driving a car? No? Okay. Something to think about. I want to ride a bike. My wife won't let me. She's like, you're gonna kill yourself. I was like, well, I got a lot of insurance. So you're fine. She'll be set. Anyways, 1.2, quantitative, qualitative, levels of measurement, the 4 levels of measurement. You have to know what they are: nominal, ordinal, interval, and ratio. So just deciding what the level of measurement is. Nominal, you're just naming stuff. Like your favorite type of car, right? So that's nominal, you're just naming it. Ordinal is an order. There was one question that was confusing. I just want to point this out. Actually, there were several questions that were a little confusing. But problem number problem 25 on page 15. The items below appear on a physician's intake form. Determine the level of measurement of the data. First level of first one was temperature. So one of the things I did mention, we want to make this decision first usually, and then that kind of helps us make the level of measurement decision. Okay, so temperature is a number, right? It's a number that we can find the average of. We can find the mean. So that's quantitative data. And then we're going to decide, is it ordinal, interval, or ratio? Okay. So if it's, come on in. If it's ordinal, then we're doing some kind of order. We're ordering body temperature. Well, it's a number and I'm measuring people's body temperature. Can you have twice the body temperature of another person? Okay, not likely. So if you could have a ratio, a fraction, that would be ratio. If you can order your numbers, that's ordinal. It's neither of those. I like process of elimination. So this one's interval. Interval level of measurement. Allergies. Okay, a physician's intake form. You're going to list your allergies. I'm allergic to peanuts. Okay. This is a name. You're just naming what allergies you have. That is nominal. Again, that's qualitative data. Qualitative is just quality. What percent of people have a peanut allergy? We could find a percentage. Okay. And weight. Weight was a little confusing for some people as well. So that one is quantitative. If you're measuring the weight, I thought about it in terms of like, well, if everyone walks into a doctor's office and they're going to measure their weight, I didn't take into consideration you could have small children, you could have adults. So you could be, I'm 3 times the weight of my son, right? He weighs 50 pounds. So that's a fraction of each other's weight. So we can use ratio level of measurement for weight. And then the last one is really confusing because it says pain level on a scale of 0 to 10. So on a scale, I use this example like on a restaurant rating. If you're going to rate the restaurant, you go to Yelp, you want to rate this restaurant, you're going to order. It's an order. It's an ordinal level of measurement because you're saying how much you like the restaurant. Okay. Even though you could find an average rating, the restaurants really use average ratings. Oh, we're at 4.2. And they're over there across the street. They're at 3.5. Okay. We don't really use mean to measure that. Even though it's a number, we could say that it's because qualitative and quantitative represent ordinal level of measurement. We can still order things if there's qualitative data. But since this is a number 0 to 10, I can find the average. The numbers have meaning. Therefore, it's quantitative data, but it's ordinal level of measurement. So that one was a little tricky there, the pain level. Any other ones? 26. Okay. Same process as the previous one. Employment application. So you applied for something, highest level of grade completed. Okay, when I first thought about this, I thought, oh, you could be a college graduate, you could be associates, bachelors, all these different, but it says grade. So I'm only assuming, 7th grade, 8th grade, 9th grade as a number. Okay, so that's the meaning of the question. That's what they want you to interpret the question as, the grade level, not a degree. So this is a number and it's quantitative. Could it be ratio? I completed my grade twice as much as you. Okay, that doesn't really make any sense, right? Someone that went to 6th grade versus someone that went to 12th grade, we can't really use ratios to compare two different people or two different things. So ratio probably wouldn't work. So I'm gonna eliminate that one. So intervals would probably be best for this one. So I would do 7th and 8th grade, 9th and 10th grade, 11th and 12th grade. Got simple intervals. I can count how many people are in each grade and find percentages. Oh, 70% of students have graduated or have gone up through 12th grade. Part B, gender. Here's naming your gender. So that's nominal, that's qualitative data. I had a student do this at the end of the semester. Another extra credit project that I usually do is, besides watching movies and collecting statistics, I do a final project. We don't have time to do a final project in summer because it goes so fast. But I usually have students do a final project. And I had a student collect data and they assign numbers to genders. And they're like giving 0s, 1s, and 2s to genders. I said, you can't do that. What if you change the numbers? Like who makes those numbers, right? So gender, you can't really assign numbers to gender. Gender is just naming something. You can't rate gender with quantitative data. So gender has to be qualitative. We can find the percent for each category, for each gender, right? But we can't find a number. Therefore, it's nominal. Just something to keep in mind. Year of graduation, time is almost always interval level of measurement. Time is quantitative. You're talking time in seconds, minutes, years, because we find the average year that people graduated from college or how many years they've been out of school or things like that. So something that happens over time is almost always nominal, or I'm sorry, it's almost always interval level of measurement. Again, you would not use ratio because you would not say, oh, your year was 1976 and my year was 2000. We can't really use a ratio to compare those two numbers. Last one, number of years at a job. So again, it's going to be a quantitative data, and you're talking years. You could have worked 1 year at your last job. You could have worked 20 years at your last job. So that's a ratio. We're comparing large numbers of data with those things. 26. Any others? Pretty good. And if you didn't get a chance to complete any of that homework and you're still stuck, okay, there's still time. It's not due until homework's not due until next week, Monday or Tuesday. I don't know. We'll see how it goes. But right now it's scheduled for Monday. Then we went to 1.3, collecting data. We have data collection. How are you going to collect your data? So we have observational study, survey. Most common, do a survey, ask people questions. Experiment, simulation. Sampling techniques is like, how are you going to collect your sample? How are you going to ask people questions? We had convenience sample, systematic sample, simple random sample, stratified random sample, cluster sample. Also a census. There's another one that they mentioned in the book. I did not mention it yesterday. A voluntary response sample. Most sampling techniques are voluntary response. Like if you go to the car dealership and get your car serviced, anybody ever do that? Your car service, the car dealership? They tell you, hey, you're going to get a phone call and please give me a good rating or else, I need to do more stuff for you, right? So I always tell you that. But you volunteer your response for that phone call. Do they randomly pick you? Probably not. Does everybody reply to the survey? No. Okay. So that would be more of a convenience sample, but specifically it's a voluntary response sample because they ask everybody to participate, but we only take the data from people that actually do the survey. Okay. So that was an extra one in there. Random selection. So I want to talk about this right now. Doing the calculator and table random digits. Not everybody had a calculator yesterday. So a couple people got the app on the phone and then they charged you or you had to pay for it. But hopefully you got that taken care of. So app, pretty useful. Make sure it looks, if you look at the app, make sure it looks similar to that. If you need a picture of someone's calculator. I use TI 84 Silver Edition. This is does not have Stat Wizard, but a lot of calculators, if you check one out from the Math Center, they're free to check. Did anybody go to the Math Center and grab one? Yeah, a couple people. All right. You just had to add the code, CRN number. That's also on our Canvas homepage. So to add that before you decide whether or not you're going to check out a calculator, but I recommend calculator required, okay, for everybody. So I'm going to press the math button. Well, first you turn it on off switch. I'm going to clear whatever I see in there. So the clear button or delete are very useful. I usually use clear because when you delete stuff, sometimes you delete it permanently and you're like, oh, geez, I didn't want to do that. So clear is best. That's your home screen. That's where you do all your math at. We're going to learn how to use all these buttons that are up in here, every one of them. There's hundreds of things that we can do with these buttons. And all the stuff in blue and green in there, we're going to use that stuff too. Right. So there's going to be a lot of stuff that for statistics in here. But the calculator best. Math. Go over to PRB. And we're going to go down to rand int. There are two questions on the homework where it said use technology. This is the technology we're using to generate random numbers. Rand int. And I'm going to get some random numbers up here. So again, it's math, PRB, or some calculators have PROB. That just stands for probability. We'll spend a lot of time doing probability. And then rand int. And it may show LB, UB, or if you have Stat Wizard turned on, it'll say lower bound and an upper bound. Okay, so your lower bound is the smallest number. Usually that's 1. So the first, we're gonna select some people, right? So if I have a class of 50 students, yesterday was 26. Today we have 50. So if I have 50 students, I'm gonna pick 5. I'm gonna pick 5 random numbers below 50. 50 or below. We can put another number here. I can put a comma and then put another number here. That just tells you how many numbers to pick. But this is a little simple. This is a simplified version. I just press that 1, 50. The comma is above the 7. I got 11. So that's the first person I pick. Person number 11. Okay, so this is random. It's an algorithm the calculator uses. Everybody probably got a different number than me because it's random number generator. Generates random numbers to randomly pick individuals. Okay. So one of the problems said pick a number between 1 and 150. Well, I just changed that to 150. If I'm using the table of random digits, a little bit different. So I'm going to go to the table real quick. And I didn't have an opportunity to put the table onto our homework, although we do have an ebook now. If you go to the Canvas homepage, you download the ebook. This is on A7, table of random digits. A7. Someone was so bored, they put together a table with random numbers on it. Don't know when it happened. I'm going to use row 10 this time. Yesterday I used row 1. So I'm just going to write down the numbers from row 10. So I'm going to look at the numbers from 1 to 150. I'm going to use row 10. So it's not actually 1. Person number 1, I got to go every 3 digits because there's 3 digits here. I'm going to use 001. 001 represents person number 1. 42103. 02781 and 73920 and 56297. If I'm going every 2 digits, like I pick these numbers from 1 to 50, I'm gonna go every 2 digits. 42, person number 42, person number 10. Those two numbers are together, 30, 27, skip 81, we don't have 81 people, we only have 50 people. Skip 73, 92, 05, person number 5. There's 5 people. Okay. If I go every 3 digits, that would be 001 through 150. Now I'm going to go 3 digits, and I'll underline those 3 digits. So I got 30, 278, 173. That's a little too big. 920, 562. So I got to keep going until I get 5 numbers that are 3 digits numbers. Okay. So there again, there are a couple questions where you had to choose, randomly select using the table of random digits. Okay. And there's no surprise, there's one of those on the quiz where you have to, it's only one question where you have to use the row and select random numbers. Okay. Any other questions? Good. All right, cool. So again, quiz number 1, you could take 2 attempts at it if you want to, or you can just wait or take 1 attempt and then wait until later. Take the second attempt later. Sounds good. So quiz number 1 probably take about, some people take 30 minutes, some people take an hour. Okay.
It would be
On Canvas. Yeah. Wi-Fi, I think you just log in with your, just like logging into the, I think they created a new, Wi-Fi last year, AHC General, I think is the name of the Wi-Fi.
I reviewed the.
Yeah. Yeah, I'm gonna put it up. Try to get on Wi-Fi. Yeah. I also brought my laptop. Anybody want a computer?
Yeah.
Log in. Anybody want a laptop? We'll take one.
Yeah.
Okay. Let me make sure I publish it first. I'd have a big data set, like a whole bunch of numbers, and the numbers are all over the place. But we want to be able to interpret those numbers with some kind of graph. Okay, and that's the goal. Because people understand graphs. People don't understand lists of numbers. One thing I would point out, someone mentioned to me the ebook that I posted up there. The ebook has slightly different page numbers than what the homework has. Okay. Same thing if you're using the 5th edition or another edition. All the problems are very, very similar, but the page numbers are off a little bit. So just go by 2.1, 2.2, stuff like that. So anyways, frequency distributions have organization of numbers. So on 2.1 in the beginning, they give us a data set of GPS navigators. Okay, so again, this book is from 2008. Everybody has a GPS on their phone now. Most people that have a phone, even the old flip phone has GPS on it. So we can ignore that GPS navigator. So I'm going to use a different set of data. I'm going to look at an age of students in the stats class. So I'm going to collect data from you, and then I'm going to talk about everything you need to know in 2.1 and 2.2 using the age of students here. Okay, so don't be embarrassed about your age. You can lie if you want to, but I'm just going to go around the room and you just tell me your age. And what I'm going to do, this is called a dot plot. So this comes from chapter 2, section 2. So I could have ages up here with different numbers. I could just list everybody's age and then find the mean, standard deviation, stuff like that. But the goal is to make a frequency distribution. And a frequency distribution just allows us to analyze the data. So I'm going to, again, go around the room and I'm going to put a dot up here for everybody's age. So we'll just go like this. We'll just start over here, Michaela, and we'll go back and forth and all the way down until we get to the end. So just shout me your age, and I'll just repeat it to make sure that I hear it. I have bad hearing too, so it helps if you shout it out. So we'll start over here.
21.
All right, 21. Another thing you can do if you have a calculator. If you have a calculator, we can go to press stat on your calculator and edit is number 1. Stat edit, and in list 1, L1, we're going to put these, you probably have a blank there. So we're going to enter these numbers into a list. And what a list does, it keeps track of all of these numbers. So when I press stat on my calculator, and then I just press enter, it shows me L1, L2, L3. Okay, is there anyone that does not see L1, L2, L3? Do not delete list 1, list 2, or list 3. Use the clear button if there's data in there. Like I have data in list 1 right now. There's numbers there. That's data, numbers with meaning. I just highlight L1, press clear and enter, and it's gonna get rid of all those numbers that are there. That makes sense? So list 1, number 1, I'm gonna enter 8. What am I entering? 21. The 21 there. So you just enter the numbers and then it'll just populate this list with numbers. Make sense a little bit? All right. 26. Age.
20.
21.
24. Maybe.
20.
18. Oh, I'm 18.
Oh, 18. See, I told you I couldn't hear.
19. 82. Oh, 32, sorry.
22. Confused you.
24. 24. 33. 20. 33. 37. Oh, me. I'm 30. 18. 18. 31. 21. 20.
All right, there we go. So this dot plot, I like dot plots because it shows the spread. Okay, how spread out are our numbers. A measurement of spread is called standard deviation. Standard deviation measures the spread of data. The mean is the average. So we can find the mean, find the average age of students in our class. This quantitative data, the level of measurement is interval. This is interval level of measurement. So what we're going to do is create intervals and count how many are in each interval. So we have 3 18-year-olds, 1 19-year-old, 5 20, 3 21s, and on down. Okay. So good spread of the distribution. I've done this for many years, and the average age is usually about 24 to 27 years old of Hancock students. Okay, so sometimes it's a little lower, sometimes a little higher. Most time right around that. That's about the mean. So we can describe the data, the distribution of the data. If I just had a list of numbers, I would want to know what is the shape of the distribution. So we have symmetry. That would be like a normal distribution, like a bell curve. That's symmetric. We have skewed left, skewed right, and then uniform. So this data looks like it's skewed to the right. Usually your skewness is towards outliers. Okay, so we have a few numbers over here, but most are in this area. So that's skewed right distribution. But we'll talk about skewness in 2.3, talk about measures of center and spread in 2.4, and we'll talk about a box and whisker plot 2.5. So chapter 2 is just measuring and analyzing data. So I wrote it right here. We collected data, that was step 1, and now we're going to analyze the data. So in order to do this, again, they use GPS navigators in our textbook, and there's no like direction, like how to construct a frequency distribution. No direction. It's in an example. So they give you an example, and in the example, they explain how to find the intervals for your GPS navigators. Well, we're going to do this with age of the students in the class. So usually what we want to do is create a histogram, and a histogram, I'll put a histogram right over here. Histograms look like this with some bars on it. Okay, that's a histogram, not a bar graph. Bar graph is at the nominal level of measurement. 1, 2, 3, 4. This has 5 bars. There are 5 classes. That has 5 classes. Usually the number of classes, this part right here is given to you. The number of classes will be given every time you have a problem. So a typical number of classes is 5, 6, 7, or 8 classes. Just tells you how many bars you're going to have on your histogram. So I'm going to look at our age, and we're going to find the class width. We're going to find how wide that interval is going to be. So we're going to have 18, 19, and 20-year-olds, 18, 19, 20, and 21-year-olds, 18, 19, 20, 21, and 22-year-olds. So this will measure that class width. So our class width, no abbreviation here. We're going to take the range. The range is the maximum value minus the minimum value. The maximum value 37 minus minimum value 18 divided by the number of classes. Again, that number is given to you. Okay, so here's a common mistake students make, and I see this quite often. N is your sample size. N equals sample size. N is how many numbers there are. And this was a couple of people had this on the calculator for the random integer. For random integers, there was an N. N just means how many numbers do you want? Okay, so we get to pick 4 numbers or 5 numbers. So N just represents how many dots there are up there. Anybody count the dots? How many dots do we have? think 24. Yeah. So n is 24. Notice we're not going to divide by 24. We're not dividing by the sample size. We're dividing by the number of classes. Okay. And all of this right here is an example 1 on page 41, or depending on what book you're using. Example 1. I'm going to do the math. 37 minus 18 is that. 19 divided by 5 is 3.8. Okay, we're talking age. Age is a whole number unless you're, 20 and a half and you celebrate half birthdays. I don't know, anybody do that? It's pretty cool. My half birthday. 3.8. We're going to round up to 4. Okay, so that's about 4. And in fact, you always round up. Always round up. So even if you have a number like 3.2, I'm going to round up. So this is an important detail with class width. Always round up to the nearest whole number. If you do not round up, then you're going to leave out data. We're going to leave out upper values. Okay, so this is how we construct the frequency distribution, or get the information we need for the frequency distribution. Then we're going to come up with the class limits. Okay, the class limits are your lower classes and your upper classes. So we just call it a class. So the lower class limit and the upper class limits. I'll give this a skip here. So the lower class limits, we're going to start with our minimum value. It doesn't make sense to start at 0. Oh, someone's 0 years old. That's not going to be the first number, because when we make a histogram, where do we start at? We're going to start at the minimum value. We're not going to start at 1 or 5 or 7. We're going to start at the smallest number, which is your min value, which is 18. So 18 is your first limit. It's called the lower class limit. There's also a thing called class boundaries. I'll talk about class boundaries where you subtract half a value or half a year. So my lower class limit is 18. So I'm going to figure out my next class, and I'm going to do this 4 more times because I'm going to have 5 of these numbers up here. So I'm going to add 4 each time to each of these numbers. Okay. So my next class is going to be 22 years old, then 26 years old, 30 years old, and 34 years old. And then the last one, I could use the last one, but usually we're going to stop there because I'm going to have 5 classes. So I got 5 numbers. We have 5 classes, so there's 5 numbers. Hopefully the math not too crazy yet. We'll get to crazy math, don't worry. If we get to crazy math, we can always use the calculator. When you're in business, you're in the real world, calculator, you get one, and you might as well use it, right? The upper class limits. So this is a little tricky. I have 18-year-olds. I have 19-year-olds, 20-year-olds, and 21-year-olds. That's 4 years. So if I go from 18, 19, 20, 21, that's 4 years. So my class width is 4. I'm including 18. Therefore, my upper class limit is going to stop at 21, not 22. Because 22 is accounted for. 22 is the lower class limit. So then I'm going to add 4 each time. I'm going to add 4 each time. So 25. Notice 1 less than 26. 1 less than 30. 1 less than 34. And then I need 5 numbers. So I'm going to add 4 more. 37. So the biggest number that I'm going to have is 37. And notice that includes our value here. If it does not include your value, then you did something wrong with your math. Okay, so that's pretty much all the calculations that we need to do. Now we're going to construct the frequency distribution. Yeah,
So why did you start with
21,
that? Yeah.
because this, there's 4 years, so from 18 to 21, we feel like there's only 3 numbers. But 18 to 21 includes 4 years, because we gotta include 18. I always do this on my fingers. Okay, 18, 19, 20, 21, there's 4 years within there. So that's why we start with 21 as the upper class limit. So my intervals are gonna be 18 to 21, 22 to 25, 26 to 29, 30 to 33. Yes?
Is it always 4?
No, we just calculated this number to be 4. This number is not always gonna be 5 either. So on the example 1, they use GPS navigators. The most expensive GPS navigator is your max value, which is $340. And your min value, you had a GPS navigator for $65. They use 7 classes. So they take 275 and divide by 7. Their class width is 40, because you're talking dollars. Okay. If I use 6 here, if I put a 6 there, then I think I still would have a 4. If we had 6 classes. If I had 7 classes, then I go 19 divided by 7, I end up with a 3. Yes.
In this problem, you pick the 5.
Yeah, 5 is
This
given.
example.
This number right here, the number of classes, that's always given. And I can refer you if you want it with the homework problems. 2.1 homework. Same thing on the quiz. Problem 29. If you have the book, it's on page 51. With 29 is political blog reading times, number of classes 5. First thing given. Book spending, number of classes 6. Problem 31, sales, number of classes 6. That makes sense? So that number is always given. That has to. That's has to be given to. Okay, so now I'm going to construct frequency distribution. So this is the construction of it, and a frequency distribution requires 5 items. We need our classes. I'm going to make a big table right now. Big table of stuff. We need our classes. We need our frequency. Hence the word frequency distribution. Frequency is just counts. How many? Okay, frequency, that's how many. We're gonna have our midpoint. A relative frequency. Relative, the word relative means in statistics, that number means percentage. Like on a barometer, your relative humidity, have you heard of that? And watching the news and the weather people, they talk about the relative humidity. Oh, the relative humidity is 90%. 90% of the air has water in it. Okay, so the higher the number, the more humid it is outside. And then we have cumulative. There's 2 ways to look at it. It could be cumulative relative frequency or cumulative frequency, either one. Relative just means that's a decimal. Cumulative frequency just means the numbers. Okay, and that's the most common is use cumulative frequency with numbers. So I'm going to put my classes up here. I'm going to have 5 classes because it says the number of classes is 5. So I'm going to have 5 classes right here. Okay, so I'm building this object to, and the goal is to make a histogram. That's what we want to do, is make a histogram. So we're going to start with 18, go to 21. Start with 22, and we're going to go to 25. I'm using these numbers right here. 18 to 21, 22 to 25, 26 to 29, And stop with 5, because he said there's 5 classes. If there are 6 classes, then I would have another interval. And again, this is quantitative data, age is quantitative. With age. This is the interval level of measurement. We're making intervals and we're just putting people into each of these intervals. We're just counting. We're gonna count how many people are in each of these intervals. So 18 to 21-year-olds, I want to know how many 18 to 21-year-olds there are in the class. Usually we'll just have a set of numbers, just like the GPS navigators on example 1. There's just a list of numbers. We're just making sense of those numbers. And that problem spiraled throughout chapter 2, section 1. So I'm just going to count the dots right here. 1, 2, 3, 4, 9, 10, 11, 12. There are 12 in this class. There are 12 18 to 21-year-olds. 22 to 25, we have 1, 2, 3, 4, 5, 6. 26 to 29, we have 1. 30 to 33. 4. And 1. And if you add all those numbers together, that's your frequency. We should have 24. There should be 24 numbers. And sometimes you'll see it written at the bottom, 24. They use a symbol, they call it the sum of F. So if you've never seen that before, F means frequency. This means sum. This is a Greek symbol. We use a lot of Greek symbols in statistics. That symbol right there means sum. Again, all the numbers that come first are called lower class limits. All the numbers that come second are called upper class limits. Put the names there. So I got the frequency. What's next? The midpoint, the halfway point. You find the halfway point between 18 and 21. And why is that important? The only importance of midpoint is helps us construct a histogram. There's two methods of making a histogram. We could use midpoints or we could use lower class limits. I like using these numbers because we already figured them out. Why do we have to do extra work? And the book, they like to give you extra work by using boundaries and midpoints. But we're just going to do it here. 18 to 21, halfway is 19.5. In the book, they show we add those two numbers together and divide by 2. 19.5. Once you get the first midpoint in my class, width is 4. So I can just add 4 each time. Instead of figuring out the midpoint for all these, I'm just going to add 4 to that. 23.5, 27.5. Can I still add 4? Those are the midpoints. Again, midpoints are only used when we construct histograms. Notice the similarity between the names. This is called frequency. In the book, they use tally marks. Okay. I hope we're beyond tally marks. We don't need a tally because I made a dot plot. Okay. Tally marks are good if you have numbers that are not in the increasing order. Anytime you see a data set, you should put the numbers in an increasing order. Right? That makes it a little bit easier. If you put the numbers into a list on your calculator, they're in increasing order. We're going to use that data in a list in your calculator a little later. But for right now, let's move on to relative frequency. Again, relative frequency is a percentage. So I'm going to show the fraction up here. You don't actually have to show what the fraction is, but I will on this. Okay, so relative frequency.
How we have the 19.5, how we get it?
How we get that? I averaged 21 and 18. So that number is, let me write like this. I'll write the first number, 21 plus 18 divided by 2. It's a little more specific in the book. The book shows the GPS navigators where you add them. Find the halfway point. Halfway.
So we always divide by two.
Yeah. So relative frequency, I take the frequency and divide by the total. There are 12, 18 to 21-year-olds. What percent of the class is that? That's 50%. Okay, well, 18 divided by 24. Oops, not 18. 12 divided by 24. 0.50. You could write it as a decimal, or you could write it as a percentage. 0.50 is 50%. So we go back and forth a lot in this class between decimals and percentages to decimals. Okay, so that's an important skill to have. Next number, 6 divided by 24. 25% of students are 22 to 25 years old. 1 out of 24, 4 out of 24. So this just gives us our percentage for each group. I'll put those on the calculator. 0.04. On the calculator, a lot of people struggle with rounding as well. 0.041666. Okay, how many decimals I'm gonna put up here? Okay, usually when you're talking about a percentage as a decimal, we'll go up to 3 decimals. So I'm gonna round it to the nearest thousandths of a decimal place, 3 decimals. Okay, 0.042. And when you add all those numbers together, you should get 100% of your data. I don't have to add up to check. I'm pretty sure that's going to be 100% of all my numbers. Again, this is almost identical to problems 29 through 42 in the homework. Pretty much identical to what you got to do on quiz number 2, pretty much identical to what you got to do on the first test. All right. Set up a frequency distribution. Okay. First time you've ever seen it. Pull it. Helps us analyze it. All right. Last one, cumulative. There's 2 things. There's cumulative frequency, or there's cumulative relative frequency. So there's 2 ways to come up with these numbers. Cumulative means sum, means total. Okay, so I can add all these numbers together. These are all my frequencies, or I can add my relative frequencies together. Okay, so there's 2 ways to do it. This one just tells us to add up those numbers. So how many 18 to 21-year-olds are there? There are 12. Then I'm going to add 6 to that. 12 plus 6 tells me how many 18 to 25-year-olds there are. 12 plus 6 is 18. And I'm going to add again. I'm going to add 1 more. That's 19. Add 4. Add 1. Till we get everybody. 24 out of 24 students are 37 years old or less. And this is, we can make a graph with this cumulative frequency graph. The fancy statistical name is called an Ogive. You'll see that in a little bit, but that all together right there, we just constructed a frequency distribution. I don't expect everyone to know it the first time you see it. That's why we practice. That's what homework's for. Okay. Also reading the book, right? When in doubt, read the book, the GPS navigators. That'll help you out a little bit as well. Like I said, I have to use my own examples for being able to do this. Math, not too crazy. Just need to know, get these numbers right. If you get these numbers right, pretty much everybody gets all that stuff right. Okay. If these numbers are wrong, then that's gonna be wrong, that's gonna be wrong, that's gonna be wrong. It screws everybody up. Okay, so the most important thing about this is getting your classes correct. What's got a mistake here? 18 to 22, 23 to 27, 28. Okay, you're off by 1. Because you'll calculate class width is 4. So I'm gonna go 18 to 22, that's 4. Well, no, that's 5 years. 18 to 22, there's 5 years there. 1, 2, 3, 4, 5 ages, okay, of students. There we go. So again, the next step would be to start constructing our graphs. We organize the data. Now I need to display the data somehow. And this is useful when you have a lot of data. We don't have very much data, 24 values. That's a really small data set. If you have 50 to 100 values, usually you're looking at an Excel spreadsheet. When I got my start in statistics, again, I was working for the National Institute of Health, an Excel spreadsheet had thousands of sets of data on there, right? And I'm like, okay, how am I going to organize this data? Well, this was really useful for using large scale data. Also, it's easier to read and then looking just at a list of a whole bunch of numbers. But we want to make a picture of that. So one of the pictures we're going to make is called a histogram. Again, there's 2 types of histograms we can make. I'll show the graphs of frequency distributions. They're down here. There's 2 histograms, and they look like exactly the same. Both histograms are exactly the same. 1, 2, 3, 4, 5, 6, 7. There are 7 bars there. So that means the class width was measured by using 7 classes. What's the difference between these 2? One uses a midpoint. One uses the lower class boundary. I'm not going to use either. I like using the lower class limit when I construct my histogram. So notice the first graph has a midpoint. The first graph has midpoints. You just put a number in the middle. The second graph has lower class boundaries. What's a boundary? A boundary, you're just subtracting half a number. Okay, so if I would need to do ages here, the class boundaries go like this. Instead of doing class limits, these are limits, I could use class boundaries. So class boundaries go like this. You don't have to do 2 calculations. Class boundaries would go 17.5. Start at 17.5, and then you're going 18.5. That's all 18-year-olds. There's 3 numbers in that interval. 19.5, 20.5, 21.5. That makes sense. That covers 4 values. Okay, so instead of going 18 to 22, we got 17.5 to, what was the number? 21.5. So 17 plus 4 gives me 21. And then the next one would be 25.5. And then 29.5. And 33.5. This is just extra work. Okay. I don't like doing extra work. Actually, I do. I got a few jobs. But that's just extra stuff that we don't need. I could use these numbers to make my graph. Okay. I'm just showing you where this comes from because that's what they show in the book. Some people are like live and die by the book. Okay, so I'm just showing you that that's a thing. Okay, class boundaries, and you might see class boundaries somewhere in the book. All right, now it's time for our histogram. So our histogram has the X and Y axis. The X axis is age. The vertical axis is frequency or relative frequency. Both of these graphs have frequencies. These numbers. Okay, so most of the time, and this was on in the last chapter, in chapter 1.2. Remember, they said the horizontal and the vertical axis, what is the level of measurement? And the vertical axis was frequency or percentage. We could use either of those. So I'm gonna draw a vertical line. This helps if you have a straight edge when you do this stuff in your notes. if you have a student ID or driver's license or credit card or something, just pull it out and plop it on your paper. Let you draw straight lines. There's a real unnoticeable thing going on here. There's a little broken axis right here. Again, I mentioned this earlier. We're not going to start at 0. Right here on this line is 0. So I'm going to start over here at some capacity, right? I'm not going to start at 0 because this is age. I label the axis. This is frequency. So we go, the biggest number is 12 frequency. So I'm just going to go by 2s. You can go by 1s if you want to. I'm going to go by 2s. 2, 4. And try to make your scale accurate as possible. Scale meaning I separate these by the same amount. My biggest histogram, my biggest bar on there was 12, which is the first group. Then age, I'm only going to put the lower class limits on there. I'm only going to use these numbers right there. My first number is 18, 22, 26, 30, 34. So each of these is going to represent a bar. I need 5 of them. 1, 2, 3, 4. I need another bar here, so I need another. I'm not going to put the max number 37 because all these are lower class limits, so I'm going to stay consistent. The next lower class limit would be 38, even though we didn't even find it. It's not part of our numbers. So 18 to 22-year-olds. How many 18 to 22-year-olds are there? Well, 22. If you're at 22, this is in this group. So we're actually doing 18 to 21-year-olds. We counted 12. I'll put a bar up there. 12. You want all your bars to be about the same width. The next group has 6. So I'm going to do as best I can to measure 6. Then 1. 1 is down here. There's 1 26 to 29-year-old. Next number is 4. I'm going up to 4. And then back down to 1. So there's my histogram. It just gives us a picture of what the data looks like. So notice what another error that some students will make. They'll put like this, 18 to 21 is right here, and then 22 to 25 is right here. Okay, so notice that's just, it's too convoluted. There's too much going on there. So using class limits cleans it up quite a bit. Okay, it's a lot cleaner, a lot neater. Again, this is called a histogram, or some people will call it a frequency histogram. What if I want a relative frequency histogram? Well, relative frequency, remember the percents. 50% of my data is here. If I make a relative frequency histogram, that means instead of frequency on my y-axis, I'm going to have percent right here. So I could use it interchangeably. I could use percent or frequency on my vertical axis. They use frequency on page 44. On page 46, you can look at page 46. I guess I could show it, not too if you will have the book. This is where they use percentage. These are all percents. And this is called not a frequency histogram, but a relative frequency histogram. Just changing the words a little bit, slightly different vocabulary. Those are percentages. So it's pretty easy to convert this to percents. I can convert that to percents very easily, right? Yes. Oh, right here? No, not at all. I just knew that they go up to 12. 12 was the biggest number. So I went by 2s. In the book, if you look at our page, you have different page number, page 44, they went by 2s as well. Just easier to count. I knew that this 1 was going to be halfway between there. There's 1. I can put marks on there if you want to. I kind of did that up here. So I went by twos up there, but if I put those extra marks, it's just cleaner, right? There's less numbers all over the place, right? It just makes things a little bit easier to read. Because again, the ultimate goal is we want to make a graph and we want people to be able to read the graph. So that is a frequency histogram. Pretty cool. And this is interval level of measurement. We made intervals. Okay. These numbers right here are right there. Sometimes they use boundaries. Like if you read the histogram, I could put 17.5, 21.5, 25.5. Those would be boundaries because they're halfway between numbers. Sometimes boundaries are used. I wouldn't use the upper class limits. I would only use the lower one. All right. There's another thing called a frequency polygon. Frequency polygons not really mentioned very much in our book and in the big picture of understanding statistics. Frequency polygons are not really that important. All it does is connect the midpoint, and this is why midpoint would be used. They use the midpoints and they just connect the dots instead of using bars. They just connect the dots of the midpoints. So the halfway point, finding the halfway point is extra work. We did 19.5, that's halfway. So I'll put a dot there. I'll put a dot, the halfway point at the peak of each of those. And now we're just going to connect those dots. And that'll give me this polygon. Okay, just another way to read a frequency distribution without the bars. If you're ever asked to read a frequency polygon, you pretty much read it the same. This dot represents 6 people 22 to 25 years old. Okay, that's it. It's a frequency polygon. Pretty uncommon graph that you'll see. Not used very often. The more common graph, I already mentioned this, is called an Ogive, or a cumulative frequency. So a cumulative frequency will have a total of all of your numbers. So all of your data, these cumulative frequencies are totals. And you can use it as a percentage. Like what percent of students are 29 or younger in the class? Okay. So that's 19 out of 24. I could just divide 19 and 24. How many students are in that age range? Oh, 19 of them. So we can use it to count how many people are in this group. So instead of going and measuring how many are in each group, it measures a total amount. Okay. So to construct this, I'm gonna try to keep this up here, because you might need it when you start your homework. I'm going to construct a frequency distribution. So again, we're going to have the ages of everyone on my x-axis. They use boundaries again. That's extra work, finding the boundaries. So I'm going to use the lower class limits that I already created. I already created those. I got a break here. We start at 18. Do the same exact thing that I did. 18, 22, 26, 30, 34. Last one, 38. So they actually go one number before this. Right before 18 would be, I guess I should scoot that over a little bit. So at 18, 14. So start right on the graph. This is 0. There's no 14-year-olds in the class. Actually, we're not gonna do that. We're gonna start with 18. Sorry. Don't do that. But not at 18. And then we're gonna go up to 12. We're gonna have 12, 18 to 22-year-olds. So as we grow in there, they use boundaries to do this. You won't ever have to construct an Ogive. Cumulative, you won't have to do this, but you have to be able to read it. Okay, what it says. I think there's one about the weight of apes in a zoo or something like that. I'm gonna go by twos once again. Two, just because it's cleaner. But I have 24 numbers now. I gotta go all the way up to 24. So I would put a dot at 12, 18 to 21-year-olds. There's 12 of those. Put a dot right about there. I like doing algebra and making a graph, I guess. The next group, there's 18. So the next dot, there's going to be 18. Put a dot there. And then 19. Put a dot just above 18. Next one, 23. Last one is 24. And just connect the dots. That's it. So how do you read the graph? You would answer some questions like, what is the 50th percentile? Have you heard of percentiles? We're gonna get into percentiles quite a bit. Like, where's half? Where's the halfway point? Well, 12 out of 24. I put frequencies up here, cumulative relative frequency, or I could just frequency. Percentages or frequencies. So right there, 50%. Okay. Half of our students are 22 and younger. Where's the what percent of students are 30 or younger? Okay. You just kind of trace back right there to that dot. 20 out of 24 students are under the age of 30. Okay, so it's yeah. Ogive, yeah. It's spelled Ogive. Ogive, like a J. I don't know. But that's the last graph that you need to know. Anyhow, we're gonna spend some time working on homework. Okay, that's the goal, is to come in. We're here for a long time. We'll work on some homework problems. I want you to at least get through problems. One problem from 31 through 42. Let me pull up the actual assignment problems on here. All right, so we have other graphs that we can make. We can make graphs that you're familiar with. We can make a pie chart. A pie chart is a circle graph. A circle graph. So if I say 50% of students here are 18 to 21-year-olds, right? That's half. 18 to 21. I can put the interval on there if I want to. That was 50%. And usually we put the percentage in there. Write as a percent, or we could write it as a decimal pie chart. Then we had 22 to 25-year-olds. 6 out of 24, that's 25%. So 22 to 25, that's 25%. 4%. Where am I getting these numbers from? Right over here. 50, 25. 4% of our class is 26 to 29. So that's going to be a small sliver. 26 to 29. 4%. And then we have our other one. Okay, so this is a pie chart. Pie chart breaks up percentages into smaller groups. A dot plot, I already gave you a dot plot. Okay, a dot plot is, you just put dots for every value. Every value gets a dot. Okay, so we already made a dot plot. That's why I started off with the dot plot. We already did that one. A bar graph. also called this is what the statistical name, Pareto chart. We're familiar with a bar graph. Okay, statistically, they call it a Pareto chart. And I'll do an example of that. It looks like a histogram, but it's not. Histograms have numbers down here. Bar graphs is categorical data or qualitative, right? So we have maybe the color of car. So then we have white car. And they're separated by gaps. We have yellow car. We have silver car. And over here we have percents, right? What percent of cars? 10, 20, 30. So that's a bar graph, okay? And sometimes bar graph has, coloring on it and stuff like that. Just to make it stand out a little bit. Sometimes bar graphs have color on it. There's a scatter plot. Scatter plot is two quantitative variables. We'll spend a lot of time with scatter plots later on. Scatter plot's not really important yet, but make it a scatter plot. Like shoe size and height. You have two variables. Okay, size 10, 5 feet, 10 inches tall. Okay, so you have an X and a Y axis, make a scatter plot, you just put the dots. Scatter plot's not really important, but the important one right now is stem, and it's called a stem plot or stem and leaf plot. So I want to make a stem and leaf plot for some data, okay? For this data. Okay, we had a stem. This is not a number, this is a line. So this is a key right here, the key 1 line 8 equals 18. So I'm going to put 4 8s here. That means we have 4 18-year-olds. This means 18, 18, 18, 18. I think we had 2 19-year-olds. We had 4 20-year-olds. So am I going to put 0 here? Or should I put 0? Down below, 20-year-olds. Okay, so then I had 20-year-olds. I had 4 of those. 1 21-year-old. I had 22-year-olds. Can't remember how many there were. We had 23 and 2 24-year-olds. And then we went up to 27, I believe. I erased the data. And then 30-year-olds. I think we had 2 33-year-olds. Oh no, we had 30. 2 33-year-olds. And 2 30. And a 37-year-old. Okay. I think that was it. Something like that. This is called a stem plot or a stem and leaf plot. It has stems. Like stem and leaf, like these are the leaves or the branches of the stem and leaf plot. So this is used when you have a lot of data. Sometimes you can make a back-to-back stem and leaf plot. Okay, so if I put another line over here like this, so let's say this is 2 different groups. I have 2 different groups. Like I'm comparing 2 classes of students. Like I have this stats class and then the morning stats class, and the ages of our stats students in the morning. So it goes backwards. The numbers go backwards. And let's say there's 40-year-old in that class. Right? Someone that's 40 years old in the morning class. So this represents our morning stats class. This represents our evening stats class and the ages of students in those classes. This is called a back-to-back stem and leaf plot. Just this by itself, stem and leaf plot. It's called a back-to-back stem and leaf plot. Sometimes you can break the stem and leaf plot in half. like if there's too many numbers, like right here, we had a lot of 20-year-olds. So I could break it up into two groups of 20-year-olds. And there's a nice picture of this one, chapter 2, section 2. It's called a I don't know if they call it a broken stem and leaf plot, but they just make two rows, or there's two stems. So for example, there are 112, 112, 112, 113, 114. There's two rows of 11s. There's two 9s, or two 7s, two 8s, two 9s, two 10s, two 11s, two 12s, two 13s. Again, that's on page 56. And there's a key there. 15 line 5 means 155. So that has a key on it. That's a pretty cool looking graph there with the stem and leaf plot. Okay. The last one, they do like they call it a time series graph. Really unusual to do a time series graph. It just, all that means is I'm going to draw a line. I'll put dots on there and something that happens over time. 2006, 2007, 2008, 2009. I'll put a dot on the graph and then connect the line. It's called time series graph. So that's, you'll probably be a little more comfortable with that. That's like problem number 14 on page 63, a time series graph. So this is looking at different graphs. So some of it's making graphs given data, or given the graph, make the data. Okay, so it goes back and forth between those two ideas. So in some ways, this is a lot easier than doing what we just did with 2.1. 2.1 is pretty tough there. It takes some time to wrap your brain around some of those ideas. But 2.2, just making graphs using data. Okay, and that's the big idea there. I only assigned, I think, the odd ones for this one. But some of the problems are like problems 5 through 8 says match the plot with the description in the sample. So you kind of have to do all the problems in order to understand how to match, right? So kind of use process of elimination to get each of those. Same thing with problems 9 through 12. So don't spend an hour staring at problem 5 through 8 and going, okay, just skip it and go on to probably number 13 or something. It's just matching. Okay. Good. All right. You can stick around if you need to. A little bit of time.